Yeah.
Okay, so we've covered steel pretty thoroughly. But steel isn't the only metal in the engineering world, right? What about aluminum alloys? Those seem pretty popular.
Oh, yeah. Aluminum alloys are definitely big players. They've got some serious advantages. They're super good at conducting both heat and electricity. And if you treat the surface right, aluminum can be an excellent reflector of light. It's actually used in some pretty high-tech applications.
Interesting.
And even though it melts at a lower temperature than steel, it actually takes longer to reach super high temperatures if it's, exposed to a fire.
Oh, I wouldn't have guessed that.
Yeah, it's kind of surprising.
Now, just like with steel, you can mix aluminum with other elements to give it specific properties, right?
Exactly. You can make it stronger or more resistant to corrosion, all sorts of things.
But how do engineers keep track of all these different combinations? There must be a system.
There is. The Aluminum Association, they've got a standardized way of naming all these different wrought alloys. They use a 4-digit number, sometimes with extra letters or numbers tacked on. The first digit actually tells you what the main alloying element is. So for instance, if the first digit is a 2, it means copper is the primary addition. And those alloys, they typically have higher strength.
Oh, that's helpful. So the first digit is like the main ingredient.
Exactly. And the second digit tells you if it's like a modification of the original alloy. So a higher second number means it's a slightly different version, maybe with some tweaked properties.
Got it. So is a code that tells you what's in it.
Exactly. And the handbook actually points out that for specific applications like, say, bearings, where you need materials that can withstand a lot of wear and have low friction, engineers will choose aluminum alloys that have those specific properties. They actually mention an alloy designated 23.0 as having the highest strength among all aluminum casting alloys at high temperatures.